There follows an interesting question about continuous random variables. I'll just briefly summarize the topic. I think of this as planes at Heathrow. Millions and millions of planes come through Heathrow, and we pile them up like this to say, how late were they? That's a continuous number, maybe 1 minute late, maybe 5 hours late. And we plot a graph of it, and we convert it into probability density. And that is to say, if we want to know how many planes were between 1 and 2 hours late, then we integrate between 1 and 2, and that area tells us the probability. Now, because every single plane is on this diagram, we can say that when we integrate across the whole range, and I've put all there because it applies to all CRVs, not just this one. When you integrate across the whole range, you will get 1. And that is because every single plane is in this diagram. So that's dead easy. Then we have the formula for expected value, which is you just take the probability density function, there it is, f of x, and you multiply it by x, and then you integrate across the whole range. Let's have a look at the question. So read the question. And what a good student realizes is A is just a constant. This isn't some kind of curved probability density function. This is literally a straight line, a straight horizontal line. It doesn't feel like that. But you must remember, x is the variable, A is a constant. It often is written piecewise this to emphasize the fact that it is a probability density function, that every single occurrence of this random variable will be between A and 3A. There are no other possibilities. So the first thing I would always think of doing in a continuous random variable question is to use the most important formula, which is this, dead easy. So I'm going to do it even though it fails. So I've integrated, and notice the integration, because that's just a constant, I just get 1 over 2a times x, put the limits in, and I get 1. And so I haven't achieved anything. However, for this question, I haven't got anything. Notice it says state the expected value of x in terms of a. I would normally be thinking, well, surely I'm going to use this formula. And this does work. Let's do it. So again, I can put limits in. And this time I'm going to have x times 1 over 2a. Get rid of that 1. And I just need to integrate that. And if you do that, it works. But why does it say state? And that is because I could sketch this. Because 1 over 2a is just a constant. It's just y equals a constant. It's a horizontal line between a domain of a to 3a. That's the diagram. Now we're thinking of this as a probability density function. So I think of it as a sort of solid block like that. This is every plane that could ever existed. And they all are between a and 3a late. So what is the expected value? Well, it's clearly just 2a. Then it says use integration to find variance in terms of a. So this one is the final formula that is on the formula book, which is this formula here. Mu squared, mu is the expected value, the mean. And then we just do this integration, x squared times the constant 1 over 2a. Do the integration and you get the answer. Lastly is going back to here, is what is the mode and mean and median? So the mean is easy. That is expected value. We have a formula for it. The mode is the most likely thing that could happen, which is most likely that a plane will be this late. So typically it's you may have to use differentiation to find a turning point, but not necessarily, just the highest point. And lastly, median is the place where 50% of the data is to the left of. So you find the median by saying 50% must be to the left. So in this case, it starts at 0, so from 0 to m of the probability density function must equal 50%. I deliberately didn't draw it at the mode because there's no reason to think it would be at the mode unless the diagram is symmetrical, which admittedly it is. Okay, cheers.